Hello again. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host, and it's great to have your company again for this, the 323rd and a third episode. Coming up, we're going to be looking at the 100th anniversary of a major event in astronomy and space science involving Einstein, which Fred knows everything about because I think he's giving a lecture on it tonight. We're also going to talk about Mars because there's been some interesting findings on Mars, and it's all to do with vibrations. Jerry wants to know about the threat from solar flares, and Tom from Minnesota on calculating distances across the vastness of the universe. That's all to come on this episode of Space Nuts.
4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
That was a false start. Just give me half a second.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me as always is his good self, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How's it going?
I am well, sir. How are you?
Good. I'm very well, too. Thank you.
That's good. Now, before we get onto astronomy and space science, did you watch the funeral last night, the funeral of Queen Elizabeth II?
Her Majesty, yes, of course I did.
Her Majesty.
I had to be glued to the TV to see, just to sort of feel as though I was on the other side of the world and part and parcel of it. And it was quite astonishing. I think anybody who watched the solemn pageantry that took place yesterday would have been very impressed with just the way it happens. You can argue all kinds of things about the monarchy and things of that sort, but for my money, the Brits do this sort of thing better than anybody else, probably in the entire universe, because they've been at it for quite a while, 1,000 years or so, something like that.
Yeah, pomp and ceremony is, that's bread and butter.
It is.
Them.
Certainly for the royal family. But it reminded me a lot of the time that I watched the coronation itself live on
Hang
the
on.
BBC.
That was
1953.
53.
Yeah, 69 years ago. Because I was a kid, of course, in those days, a youngster. We were the first house in our street to have a TV set. So
wow,
all the neighbours were in. Yeah, we were posh, yeah. Not that posh, though, I can tell you. The neighbours all came in, and there was a bit of a party going on. And I remember my brother and I sitting, my brother's younger, he's 3 years younger than me, sitting watching all this. But we'd been given gifts by, I don't know whether it was the local council or the government or the royal family themselves, but we got things. We had a mug, a coronation mug. I also had the coronation coach, a little toy of the coronation coach and all the horses. Right. But we'd also been given a penknife each, which was really useful. But the highlight of the broadcast, when we were all sitting watching the coronation, was when my brother John cut his finger with the penknife and there was blood everywhere, which was quite a dramatic, not quite an end to the proceedings, but it certainly distracted from the solemnity of the coronation.
I can imagine.
But, actually, just as an aside, I grew up in the 1950s, obviously, and having a young queen like that, somebody who, right from the word go, they all loved her. They didn't have to work hard to do that because, they loved her father, George VI, who died quite young. But they loved Queen Elizabeth. And it was the new Elizabethan era. It was quite striking. And Britain was kind of doing things and going places, but gradually got overtaken by all sorts of other things.
Yes.
It was a remarkable time to be alive. And yes, the proceedings last night took me back to all that. And
did you ever meet her?
I did, but with 30,000 other school kids.
Oh, right. Same.
Yeah,
Sort of.
Yeah, that's right. And we sang to her, which I'd forgotten all about until a couple of weeks ago. I watched the video just because you can get all this on newsreel, ex-newsreel stuff now. And sure enough, there's footage of 30,000 school children in Bradford in Yorkshire singing On Uclamore Bartat, which is a Yorkshire song, to the Queen in 1954.
It's amazing how long that papyrus tape lasts.
Yeah. It was a bit like that.
Incredible.
It's astonishing that they've still got it, but it's great.
Yeah, she will be sadly missed, and her son has got big shoes to fill.
Indeed, that's right. Yeah. But
I can see the strain on his face too. The poor fella. I feel for him. He's grieving while having to run the
empire. As it used to be. We have a connection with Charles, though. He opened the Anglo-Australian telescope in 1974,
right.
And when we celebrated the telescope's 40th birthday back in 2014, Marnie, my other half, wrote to the Prince and said, we're celebrating 40 years since you opened this telescope. Do you want to come and do a bit of a gig with it? And the answer, of course, was no. But we got a lovely letter back from one of his aides, which said he remembered it fondly and had followed the progress of the telescope with interest throughout its career and wished it well for the future.
There you go.
Yeah, it's pretty impressive. Yeah.
We'd better get on with it.
Well, that's kind of vaguely astronomical.
It was, yeah. Well, it dovetailed nicely.
Yes, indeed. Segue.
Now, let's talk about Einstein's Eclipse. Now, I must confess I don't know a lot about this. I have seen things popping up in astronomy news, but you're right on the pulse of this because you're giving a lecture on the subject.
Yes, but I give lectures on many things that I'm not actually on the pulse of, Andrew. But I am on this because
like space nuts.
Yes, that's right. It's something that caught me a bit by surprise. Actually, the fact is that we celebrate the proof of relativity. And I'll say a little bit more about that in a second. But we celebrate that as having been in eclipse on the 29th of May, 1919. So what the story is that Einstein published his general theory of relativity in November 1915. And of course, it says that space is bendy, that mass actually distorts space, and we feel that distortion as gravity. That's the bottom line of the theory. And that is a bizarre idea. Only a loony would believe that. And so the impetus was on to try and prove it. And there were eclipse expeditions, some of which have got quite sad stories. There was one that somebody who's in a way connected with me, a man called Erwin Freundlich, who was one of Einstein's colleagues at Berlin Observatory. And Freundlich went to try and observe an eclipse in 1914, just before before Einstein had finally published his work. But he knew that an eclipse was the way to prove it. And sadly, it coincided with the First World War starting. So Freundlich got locked away somewhere for several months.
I think I heard about that. Yeah.
Yeah. The connection with me is that he's my academic grandfather. My master's supervisor, it was his supervisor. So there's
how about that?
Yeah. My one claim to fame. Anyway, cutting all that short. So the way to prove this weird theory was to observe stars around the edge of the sun during an eclipse when the sun's light is blotted out by the moon, which means you can see the stars beyond it with big telescopes, measure their positions really accurately, do the same thing 6 months later when the moon's not, the sun isn't there, and there's a difference between them, the positions of the stars. In fact, the stars will look as though they're being deflected away from the sun.
Yeah.
So you measure that deflection, and when they did that, they can demonstrate that relativity was correct. Now, with the 1919 eclipse, there was only a handful of stars for which measurements could be made. It was Arthur Eddington who made the measurements, but nevertheless, it was enough to convince people that relativity was real, and so that's always hailed as the the smoking gun that proved relativity back in 1919. In fact, the headlines were all over the world. It was accepted that relativity was a fact. But there were a lot of astronomers who knew the details of what had been done and were not that happy with the outcome. They were worried that the result was that it could have been wrong, that it could have been a negative proof. In other words, that you failed to demonstrate that these stars had been deflected by the mass of the sun by the amount predicted by relativity. And so there were several attempts to observe other eclipses, which culminated on the 21st of September, 1922, when an eclipse came. It was across the Indian Ocean, passed across Christmas Island and right across Australia from west to east.
Right.
So there were 5 expeditions. One of them was a private expedition, just a man and his daughter, but she was a professional photographer, and so there were results to report. But the expeditions were along the line of the eclipse, starting in Western Australia at a place called Wallal. It's on the 80-mile beach, which is not far from Broome, and then culminating in Goondiwindi on the border between Queensland and New South Wales, and a place called Stanthorpe in northern New South Wales. And there was another place as well. So various measurements were made. These different sites had hosted different expeditions. The most important one was mounted by Lick Observatory, which is a big observatory in California. They had one of the biggest telescopes in the world at that time. And that observatory also liaised with the University of Toronto and New Zealand astronomers, and also astronomers from India. So they mounted a huge set of observations, enormous quantities of equipment. They had wonderful support from the First Nations people in the area because it's a very remote place. And unusually, there were 5 women on that expedition as well. One of them was the director's wife of Lick, but she was an astronomer too. And that's, remarkable. So they produced the most spectacular results. Further down the track, there were other expeditions. University of Adelaide had one, Sydney and Melbourne observatories had one, a bunch of amateur astronomers had one. And that bunch of amateur astronomers were led by a man called Walter Gale, who is commemorated in many of our conversations about Mars, Andrew.
Gale Crater?
Gale Crater, where Curiosity is named after Walter Gale, an Australian astronomer.
Well.
But the results from the Lick Observatory team in Wallal and Western Australia, they analysed the positions of more than 100 stars and proved quite conclusively that, yes, relativity was real. And they sort of drew a line under that question mark. And since then, of course, there have been many, many different measurements, including gravitational lensing, all of these things that demonstrate that relativity works.
And still many attempts to prove him wrong.
Yes, well, that's right. But on this level, he's definitely right. Relativity works to about 1 part in 10 to the 18 or something ridiculous like that. We'd love to have it proved wrong. One of the things I really liked about this story, though, Andrew, is that in Goondiwindi, which is a small town inland on the New South Wales-Queensland border.
Been there many times.
Yeah. I've been through it many times on the way north. But they were relatively easy to get to because they're on a railway line.
Yeah.
And many, many people came to watch the eclipse, and it became quite festive for days and days beforehand.
Yeah, that sounds like Goondiwindi.
And anyway, a poet, a bush poet, and bush poetry is something that's very characteristic of Australia.
It sure is.
A bush poet by the name of John Sands, who wrote in a Melbourne newspaper called the Argus, he published a poem called The Passing Show on the 16th of September. And if I may, I'm going to read a few verses from that.
Yes, please.
Right, here we go. Then the news ran round the stations and raised the squatters' hopes when scientists got busy and unpacked their telescopes. And the cowmen flocked to the township in eagerness to see the testing of Einstein's theory of relativity. There were telescopes and cameras and gadgets by the score. Then Baldwin's crowd from Melbourne town brought just as many more. Yet still they came, those scientists, in dozens and in scores, until the Gundawindians were forced to close their doors. By train they came and motor car, by horse and four-wheel trap. Gundawindi smiled serenely. It was once more on the map. And the squatters and the cowmen, why, their knowledge scientific defies all explanation. It was simply, well, terrific.
That is fantastic. Yeah. Gosh, there's some clever people out there that can string those things together.
Isn't it amazing?
Yeah.
So,
because the locals call it Gundy. They just
Gundy.
We abbreviate everything, so it's Gundy.
Gundy Windy. I apologise. I've never been able to do an Australian accent, but that was the best I can do.
Oh, is that what it was?
Yeah.
I heard a little bit. There was a bit coming through.
Yeah. I've only been here 40 years, Andrew.
It's very hard to change.
Yes, it is.
I met a French woman who moved here when she was very young, and she's bilingual, but this was a week or two ago at a writers' festival, and she has the most normal Aussie accent you've ever heard. And I just said to her, well, where's your French accent? She said, I don't have one. I said, why? She said, because I've lived here for so very long.
Yeah.
She was young enough to come here to wipe it out.
That's right. Yeah. Yeah.
And I should have asked a follow-up question like, well, when you speak French, do you have an Australian accent?
Yeah. She probably does, actually.
Yeah, I would think so.
Yeah, my wife's fluent in French, but she lived for a long time in the south of France, so they all think she's a southerner when she speaks French. Oh, yeah, from the south. Yeah.
So you're giving a lecture on the anniversary of the confirmation of?
Tonight, that's right. We hope we'll be able to get it online as well. This is a face-to-face lecture, but there might be something eventually. Actually, I might just, while I'm talking about that, Andrew, if I may, plug. There is a book which is coming out next year. I'm afraid it's a while yet. I think it's March when it's supposed to come out. It's called Eclipse Chasers, and it's about eclipses in Australia. And it's written by friends of mine, Tona Stevenson, Nick Long, both of whom are ex-directors managers of the Sydney Observatory. They've edited it, and a number of other people have contributed to it. There's a marvellous chapter, though, on this particular eclipse.
Fantastic.
I've had a preview of the book. It is a stunning book, so we might mention that again next year.
Yeah, of course, we've got a big one coming up in about 6 years, is it? 2028?
Yeah, 2028, that's right. It goes right over Dubbo and right over Sydney.
We'll be almost at the centre of totality.
Yeah.
In fact, 40 kilometres out of town at Ballymore, I think, is where they'll be right in the middle of it.
Yeah.
I hope it's a nice day.
So do we.
Yeah. Anyway, we can talk about that later.
I think we might be able to talk about it later.
Yeah. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Okay, let's take a quick break from the show to tell you about our sponsor, NordVPN. Now, NordVPN, as I've said many times, is the best service in the business. They've got the fastest servers, they've got the best encryption, and they will protect 6 devices at the same time, and that includes your smart TV. Now, a virtual private network is just like putting up the Great Wall of China in front of your privacy. That's the most simple way of describing it. And as a Space Nuts listener, you are entitled to a really good deal with our sponsor, NordVPN. Now, when you go to the website, and it's a special URL, nordvpn.com/spacenuts, you'll be met with the page that has a little button that says use the coupon. Now, please note, there is a 30-day money-back guarantee with NordVPN, so you can buy with confidence. And what they're offering is a cyber security package. It's not just the virtual private network that you're getting. You're getting a whole ream of tools that will protect you from hackers and whoever else wants to get hold of your personal data. And they offer you a
plus 4 months package as well. So you get bonus months when you sign up for NordVPN. So click on the use coupon code, and don't forget that the special code is Space Nuts if you need to type it in. But they have several plans available. Now, the plan that I'd recommend is the complete package. It saves you 69%. And it gives you high-speed VPN, malware protection, tracker and ad blocker protection, cross-platform password management, data breach scanning, and best of all, or in addition to, the 1 terabyte of encrypted cloud storage. Cloud storage is the way to go. I use it all the time, and I find it so handy. It just, you know, everything's safe. If your computer dies, it doesn't matter because it's all backed up. It is a really fantastic tool, and it's part of the package. If you don't want to go all the way, you can buy the intermediate package or the standard package, or standard plus and complete. Anyway, look it up. Have a look at it. nordvpn.com/spacenuts. Pick a plan that suits you. You've got a few months up your sleeve to decide whether or not it is for you. I'm confident that you will be most impressed and very satisfied with our sponsor, NordVPN. So go to the special URL, nordvpn.com/spacenuts for your special price and extra benefits as a Space Nuts listener from our sponsor, NordVPN. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, let's head off to the red planet. This is all about the ongoing study into Mars quakes, but now they've been able to sort of get down and dirty with the vibrations, and they've honed in on a bit of stuff.
Yeah, this is really nice science. It's just, the kind of thing that you live and breathe for in the world of science. And actually, if anybody wants to follow this up, there's a very nice article on The Conversation by a scientist from Curtin University in Western Australia, Katerina Milkovic, I think is the way you pronounce her name. And Katerina has written this account of the fact that basically one of the spacecraft that's on Mars has been able to locate impact craters from meteorites on Mars by detecting the shock waves that they send. So what's the story here is that InSight, which you might remember is it's not a rover. It's been there, I think, since 2016, based on basically a flat sheet of metal with legs on it, and it's got solar panels on it, which apparently are caked up with Martian dust at the moment. So there's possibly no more power coming through, and perhaps by the end of this year it will die. But the InSight was equipped with famously a drill to plant a thermometer down in the soil. Which never really worked properly because the idea was to measure the heat flow from Mars's interior. It was all about detecting things from the interior of Mars. So that was a bit of a dud. But the other part of it was its seismometers, and the seismometers actually were basically there to see whether we could hear anything coming through the rocks of Mars. Yeah. And they've detected in its history, actually 2018 was, I think, when it landed there, not 2016, more than 1,300 Mars quakes have been detected. And so there's a huge amount of data there. And what they've been able to do is do some really clever work that's allowed them to use these seismic vibrations coming through the rock or through the seismometers to use that to detect something landing and then to identify the crater that it's caused, which you can do from one of the orbiting spacecraft, Mars Express or Mars Global Orbiter and things of that sort. Mars Reconnaissance Orbiter, let me get it right, and another active orbiting spacecraft. So what the trick is that you get not just if something comes from space, a meteor, which is zooming through the atmosphere, and he's going to be a meteorite because it'll land on the ground.
Yeah.
Mars's atmosphere is only 1% as dense as the Earth's, and so it behaves in a different way. Plus the fact that it's made of carbon dioxide mostly, which is different from what we've got. So meteors behave in a different way, and quite often you get a double bang, two sort of explosions. One which is called the first airburst, and another which is called guess.
The second airburst.
Oh, well done, Andrew. Well done.
That was hard.
Oh no, it's hard work, isn't it? So you get these two, and they send acoustic waves down to the ground, which vibrates the ground.
Yep.
And it's the timing of this. It's all about timing. So InSight detects the vibrations in the ground and does it very accurately with timing. And it can also sense the direction as well to some extent. So what you've got is a direction and a distance to these two airbursts. And that means you can then plot a trajectory for the incoming meteorite, and you can get an idea of where it will have landed. And they've actually been able to do this and then used, the Mars Reconnaissance Orbiter observations to actually look for the new craters. And sure enough, they've found them. Yeah. I think that's an astonishing result.
It is. They've even published photos.
Yes, they have. Yeah, that's right. And some quite interesting diagrams. Actually, in Katerina's conversation piece, there's some nice diagrams as to how it works and how they're able to actually do this science. It's a very impressive piece of work. And, of course, it involves our favourite planet and involves quakes and things like that. It's got everything, isn't it?
Yeah. Now, they do think most of the quakes are caused by these impacts, but are they detecting any that are coming from inside Mars?
Yes, there's been a number, quite a few, some of which you and I have spoken about in the past, I think, caused possibly by shrinkage. The fact that the crust is shrinking a bit, and so you get wobblings.
Yeah, so it's not likely that it's some kind of activity within the planet. It's more like deactivating that's causing it.
Yeah.
Bit sad. Mars is getting old and starting to wrinkle. That's really all it comes down to.
There's nothing wrong with that.
I tend to agree. All right. But that's really, if you want to look up that article, it is on theconversation.com. It's worth looking at. It's not a massive article, which is unusual for the conversation, but
yeah, that's right.
It's a really good read. So check it out. This is Space Nuts. Andrew Dunkley here and Fred Watson.
Okay, we checked all 4 systems and team with a go.
Space Nuts.
Now, Fred, let's tackle some questions. And this first question comes from Jerry. Hi, Jerry. Thanks for texting into us. Hello, Andrew and Fred. I love Astronomy Daily. Oh, thank you. To get the latest up-to-date celestial happenings. And I love Space Nuts because you and Fred go into such detail explaining things and answering questions. My question is, since a lot of the world is going solar panels, including electric companies and cities, is it possible that a major solar event could short them out or melt the electronics, rendering them useless someday in the future? It could be an expensive failure and major disruption in electricity, etc. Jerry, thanks. Great question, Jerry. And, your timing is perfect because I was only just reading about a sunspot, AR3089, which they're keeping an eye on because they're a little bit worried about it. Did you get that? They're keeping an eye on. But they're a little bit worried about it because it's even though it's quiet at the moment, it's developed a delta-class magnetic field which has the energy of X-class solar flares, and that's the strongest class of solar flare. But it's a variable thing. But potentially an X-class solar flare could release as much energy as 1 billion hydrogen bombs at the most intense end of the scale, which is scary to think about. So they're keeping an eye on that one. So if something like that hit Earth, would it destroy all the solar panels? Like where I live, Fred, in good old Dub Vegas, in central New South Wales, we have per capita more solar panels on household roofs, including mine, than anywhere else in, I think, New South Wales, but possibly Australia.
Australia, yeah. I'm not surprised. I mean, you do get a lot of sunshine there in your
we do.
city. Well, you used to before it started raining.
Well, this year is an exception, but most of the time, we get just piles and piles of sunshine.
So I think actually, if you've got an X-class flare that's sort of super flare, and something that might be comparable with the Carrington event, which was it 1869 or 18? I think it was 1869.
And blew up all the telegraphs.
Yes, it did. Yeah, but fried all the telegraphs in the USA, which were just starting to be laid by railway lines, and that. It was associated with a sunspot group. It was observed by an astronomer called Carrington, who noticed a very distinct brightening of this spot on the sun. And that turned out to be this solar flare, which released a lot of energy in the direction of the Earth and did all this damage. Now, a Carrington event today, would be critically dangerous in many ways. And it's one of the things that space engineers have tried to harden their satellites against, so that you've got, all the delicate the most sensitive electronics are inside some fairly serious shielding. Yeah. But we're still left with everything on Earth. And was it 1989, if I remember rightly? There was a similar event. It wasn't Carrington in scale, but it wasn't far off, that wiped out the power grid in I think it was Quebec in Canada.
Oh, okay.
And I think they were left without power for 12 hours, 9 million customers, if I remember rightly. And that's because when you've got these long power delivery cables, and we live quite near some of those, big pylons with their sort of striding across the country with their cables attached to them. Yeah. What you get with solar flares is highly magnetized regions. You're sweeping magnetic field lines across these wires, and what that does is generates a current. It's how current's generated. And so you actually add to the current that's traveling through the wires, and it blows out all the safety equipment. Everything triggers so that the whole thing shuts down. That's what happened with the Quebec
March the 13th, 1989, at 2:45 in the morning.
I got the year right.
Yeah.
9 million, was it, households that were left without, or something? 9 million consumers?
Well, it doesn't give me a number here that I can see. This is on NASA's website, nasa.gov/topics, but it did black out quite extensive areas around Quebec and other parts of North America.
Yeah, so that's the result of an X-class flare on long heavy-duty power cables. Now, I guess the alternate question is, all right, so what happens when magnetic field lines like that sweep across the cables connecting your solar panel to your power, your power center in the house? And I don't know what the answer is to that. I would guess that there would potentially be damage. There could be risk from things catching fire. Yeah. But I don't know whether you're any more sensitive to damage if you've got solar panels and you've kind of off the grid or something. Whether you're more sensitive with that than you are with a mains power, something that is on the grid. I'm not enough of an engineer to know the answer to that, but it's a really interesting question. So I think for Jerry, the answer is maybe.
Maybe. Of course, for it to be an extensive hit, it has to be a direct hit. It's got to broadside the planet, like firing a salvo from a ship. You've got to hit it dead center.
Yep.
So if we get glanced, it might not do much. Although they do have a space weather warning system now for things like this.
All of that's sort of inbuilt. At least the one thing we do have now that they didn't have in those days is a very complete space weather warning system with lots of spacecraft which are monitoring the sun all the time and looking at exactly these things so that they can send alerts out to people like you who listen to spaceweather.com.
Yeah. Yes, there have been isolated incidents over the years, and there was one blackout spot that was caused only a year or two ago in the middle of the Atlantic Ocean. So,
yes, that's right. Yeah.
And so it affected shipping more so than anything, but and dolphins. But it's
Do they have radio?
they have wires
probably
in their head. Yeah, the ones used by the US Navy apparently.
Oh well, yes, of course. There's that too.
Yeah,
that's right.
I don't know,
Yeah.
but yes, the answer, Jerry, is perhaps, and let's not hope we find out because I'm still looking at AR 3089 and.
Well,
yes.
Keep us posted, Andrew.
We might find out before I have to keep you posted. Who knows?
You might not be able to keep us posted.
That's a possibility too. But can you imagine if a doomsday scenario like that happened and electronics across vast areas of the world were just wiped out?
Yeah, I know.
Be going down to the river with a bucket to get more water. That'd be
exactly. It's all of that. That's right. Everything uses electronics these days.
It does indeed. Yes. All right. Thanks, Jerry. Lovely to hear from you. Let's now go to Minnesota, where I believe Tom is hanging his hat. He's got a question for us.
Hello, Fred and Andrew. This is Tom from Minnesota in the U.S., and I have a question about calculating large distances between the Earth and deep space objects. So when we see a headline that says something like, Webb captured a photo of a galaxy that's 13 billion light years away, I'm assuming that galaxy is not exactly 13 billion light years away. So I'm curious if there's some sort of standard practice for rounding large numbers such as this. Perhaps you're always supposed to round up or down or to the nearest decimal point. I find it fascinating to think that if you were to round to the nearest decimal point, you could potentially be wiping out 100 million light years of distance. Any information on this topic I'd find incredibly fascinating. Keep up the good work. I'm a huge fan of the show. Thanks.
Thanks, Tom. I'm sorry to tell you, everything is exactly to the round figure away from us. It's just a weird coincidence.
Isn't it just, yeah. No, Tom's right on the money with the rounding. And it's just, astronomers just do what you do in any science that's quantitative, that involves numbers. You don't quote the figure to more decimal places and the accuracy of your measurement will stand. And so that particular number that Tom mentions, the age of the universe, 13.8 billion years, I seem to remember from the last time that was estimated, which comes from the cosmic microwave background radiation, it was with an accuracy of something in the region of exactly the number Tom mentions, 100 million years. And so you can quote it to a decimal of a billion years if you're good to 100 million years. So 13.8, it could be 13.9, could be 13.7, but 13.8 is the most likely. So, if you were being pedantic, you could say 13.8 plus or minus 100 million years. And
I suppose the problem also arises with, publishing a scientific paper about something that's so far away. If they went to the maximum decimal place, there's 3 pages of their paper.
Well, yes, that's right. But you don't. The thing is, if what you're doing, if you did that, you're putting more decimal places in something than are meaningful in terms of your measurements that you've made, and that's why one part in 100 million years. An error of 100 million years is quite a long time. It's on earthly standards. So the 66 million years since the dinosaurs were wiped out, that's within the error. But for something as esoteric as the origin of the universe, it's not a bad answer actually. But we also, just to add to this debate, and you and I have spoken about this. If you measure the age of the universe by the expansion of the universe today and compare it with the cosmic microwave background radiation, you get 2 different answers, which differ by something like 3 or 4%. Now, that's still less. That's still within the 100 million year error in the age of the universe, but it troubles people. So what you're seeing here is that as our estimates get more and more accurate, you get more and more worried about different estimates that diverge from each other. So even though I think you can say with confidence 13.8 billion years is our best estimate of the age of the universe, with the slight differences in the what's called the Hubble constant, which is actually one of the things that determines that.
It's fascinating, if not comical, to read articles from time to time where the numbers bounce. Like some people say 13.5, some people say 13.8, some people 13.7. So you've got to wonder where they're getting their numbers from.
Yeah, I see that a lot. And it's, I mean, I have tended to concentrate on the numbers that came from the Planck spacecraft. Planck, not a piece of wood, but Max Planck. It's a European spacecraft which did its work a decade or so ago and gave us the best estimate from the cosmic microwave background radiation. And I think it was that was 13.8 plus or minus 100 million years, which is a better estimate than there were two previous spacecraft measuring the cosmic microwave background before that, COBE and WMAP, and each one of those successively got a more accurate answer because they were able to see more detail in the background radiation.
So in terms of a distance to Alpha Centauri, for example, would we be able to give an exact distance? Because everything's moving. So it wouldn't always be one number.
No, it wouldn't. But the movement on human timescales is less than the error in our measurements.
Right.
Because Proxima Centauri is one of the stars that you can measure by what we call the parallax method. You measure its position when the Earth's on one side of its orbit, compare position on the other side. Right. And that gives you a really accurate distance. But you're quite right, it's moving. And so, in fact, I think Gaia, which is a spacecraft measuring positions very accurately, I think it can measure to something like a millionth of an arc second. Arc second is 1/3600th of a degree. It's a tiny angle. But a millionth of them is even tinier. And I think with Gaia, they've been able to measure that change in distance accurately as it moves, because it does move quite quickly through the sky.
Yeah,
Proxima Centauri. Yeah, so really interesting stuff. So you can give when I say an accurate answer, you probably still only to 2 decimal places of a light year, but that's pretty good. 100th of a light year will be very accurate.
But for the sake of simplicity, we just round up or round down.
4.3, that's right, 4.3 light years. Yep.
There you go, Tom. It's just a rounding thing. It's just lazy humans, basically. So can't be bothered wasting the ink on all those extra numbers. That's really...
Yeah, because they don't mean anything.
Yeah, well, it's the cost of ink, really. That's the problem.
Right.
That's what it is.
That's a problem.
Yeah. Thanks, Tom. Lovely to hear from you. Hope all is well in Minnesota. We're just about done, Fred. It's all over. Red Rover.
Yes.
Yeah, but of course, if you have questions for us, we'd love to hear from you. All you need to do is send them, which you can do in audio format on our website or as a text on the AMA tab, where you can do both, or you can click on the link on the right-hand side that says send us your voice questions. And if you've got a device with a microphone like I have, you can record it. I'm going to try it one day, actually. Did I ever show you my phone case? My grandchildren made this for me.
Oh, that's lovely.
That's me playing golf. I might have shown you before.
No, I haven't seen that before.
Yeah, and that's a heart, not a bum.
Yeah.
And I think that, hang on, it might be on the inside. Oh, yeah, that's little Harry, my 3-year-old. That's a tortoise. Tortoise right there. That was their Christmas present to me. So it's funny,
decorated. Yeah.
Whenever I take it out because I've got all my credit cards and everything in here, whenever I take it out to pay for something, if there's a young girl at the checkout, she says, "Oh, I love your case. Where'd you get that?" And I say, "Well, actually, it's homemade. My grandchildren did." So there you go.
Yeah, very nice.
But yes, send us your questions and don't forget to do some reviews. We're beginning some really good ones lately. So thank you to those who've uploaded reviews through their podcast platform, because we want to grow our family, and the only way is reviews. The more reviews, the more people that notice us, the more people who join Space Nuts, and the more people that can talk to each other on social media at the Space Nuts Podcast Group Facebook page, etc. So yes, please send us your reviews. I think we're done, Fred. Oh, don't forget to visit the Space Nuts shop while you're there. There's plenty of goodies. You've got one of those. You can get one of those. I know you can't. I made that. But there's a cup there, and there's stickers. See? Oh, they're on the shelf, but they're there. And much, much more on our shop on spacenuts.io. Thank you, Fred. That's where we're going to wrap it up. Lovely to catch up with you again.
And you too, Andrew. And have a good week, and we'll speak again soon.
You too. Take care. Professor Fred Watson, astronomer at large, and from me, Andrew Dunkley, thanks for listening or watching or both. And we'll catch you again on the very next episode of Space Nuts. Bye for now.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.